Okay, what we are covering for today in class, we're moving into that multiplication and division component a little bit further. So we talked about the properties for multiplication last time. So what we're covering today, you can multiply and divide rational values in word problems. That's contextual problems. You can also convert fractions and decimals through division. So you're going to be utilizing that long division. So the first thing that we're going to do, this is our little warm-up, is just to kind of go over or reiterate again those key operational vocab terms. So what indicates a multiplication problem versus a division problem? So for multiplication, you obviously have some simple ways to identify it. You might see the word multiply or times. Product is a little bit something different. This is actually an answer. Okay, product represents an answer to multiplication. So when I say the word product, I'm talking about the answer of a multiplication problem. That means that you should have already multiplied it. So if they're saying, hey, it's the product of 7 and 3, you know that it's the answer to 7 times 3. Okay, you would do 7 times 3. You would know that that was 21. The product is 21. Okay? You've got conceptual or contextual problems like area. Area is a math problem that involves multiplication. Okay? You've got some key vocabulary that not only indicates multiplication, but it indicates what you are multiplying by. So if I say double the value of 10, then you know that you're going to take 10 and multiply it by what? Logan? 2. Double or twice. These both are indicating that you are multiplying by the value of 2. So I'm going to put times 2 right next to them. Triple would mean that we're multiplying by what value, guys? 3. Okay, if I said quadruple, that would be times what? 4. Okay? And then one value that people, or a term that people tend to confuse sometimes, the word by. By can also indicate a multiplication problem. Okay? And one thing that's not written here that I would like to go ahead and put down at the bottom, per, each, and every. Write this down. The terms per, each, and every. They could also be indications of multiplication. Okay? If it's not in the question. That's an important thing to understand. Okay, so if I'm saying it's $3 per banana and we have 8 bananas, then what's the cost going to be for the bananas? Then that's going to be a multiplication problem. We're using the word per or each or every within the situation, but not necessarily in the question itself. Okay, division. Division has its own vocabulary. So we've got obvious things when we say that we're splitting stuff up into equal parts, or if we're going into how much does it go into, or how much can you divide. You're creating a ratio, a fractional value. Fractions are all division, guys. Look at your division symbol. A division symbol is a fraction with a dot at the top for a numerator and a dot at the bottom for a denominator. Fractions are divisions. Okay, if I say to take half of something, we know that we're dividing by what value? 2. If I take a third of something, we are dividing by 3. Take a fourth of something, we're dividing by 4. Okay, it keeps going on. And then you've got quotient. Just like product was an answer to multiplication, quotient is an answer to division. Quotient is an answer to a division question. So if I say, hey, you're going to multiply 7 by the quotient of 24 and 3, then you know you're multiplying 7 times 8, because the quotient of 24 and 3 is 8. Okay, now per, each, and every can also be utilized in division if it is inside of the question. Per, each, and every, if it is inside the question. Okay, so I'm traveling 5,000 miles to get to a destination, and my speed for the airplane is 500 miles an hour. So how, splitting it up into equal parts, what is the hours that it's going to take me to get there? You would take your mileage total and divide it by the speed, and you would have your hours. If we're saying that, okay, we spent $20 on, food, and then that we bought 6 items, how much was the cost per item? Okay, per being in the question, that would utilize a division problem, that you're taking your cost and dividing it by the number of items. So there's all sorts of different things that you can utilize for division versus multiplication. Okay? So what we're going to do right now, we're going to go through a couple of problems together. We're going to identify key vocabulary that represents multiplication or division. We're going to work the problems out, and then I'm going to let you do the rest of those problems on your own to see if you can identify the correct vocabulary. So let's start with problem number 1. Elena overdraws $25 on her account every day for 4 days. So how much total is her account overdrawn by? She overdraws $25 on her account every day for 4 days. How much total is in her account overdrawn by? So first thing that I want to do is I want to identify my operation. Am I multiplying or am I dividing? Fatima? Multiplying. How do we know? What keyword let us know that we are multiplying? Every. The keyword every. The keyword every was inside the problem, but not inside the question, right? The question does not have the keyword of every. So we've got the term every. We're doing this every day for a certain amount of days. That's going to indicate to us that it is multiplication. So we know that we are multiplying in this problem. So now we need to identify the values we are multiplying by. Elena overdraws $25. That's one value. What kind of value is that? Positive or negative? Richard? Negative. Very good. Because what keyword lets you know it's negative? Overdraws. Overdraws means that you're taking money that you don't have. That's what overdraw means. So that identifies it as a negative 25. What's the other value that we're multiplying by? 4. And is it positive or negative? How would you know? Say it. Go for it. Because a day cannot be negative, guys. Time is never negative. Days, hours, months, years, weeks, seconds, whatever measurement of time that you're using, time is always a positive value. So that's how we know. The fact that it's identifying it as a day, 4 days, days are never going to be negative. They're always a positive value. So we're doing negative 25 and we're multiplying it by a positive 4. Okay, so negative 25 times positive 4. First we've got a negative multiplied by a positive. Negative times a positive will always give us what kind of answer? Go for it. Negative. So I know my answer is going to be negative. So now I just got to focus on 25 times 4. 25 times 4 is 100. So she's going to have a total overdraw of $100. So negative $100. I'm just going to put a dollar sign there. Okay, let's do one more together. Alex's team lost a total of 54 yards in the first quarter. All 9 players lost the same amount. So how much did each player lose? how much did each player lose. Okay, operation. There's actually two ways that you could identify the operation here. What's one of them? Montserrat? It says each inside of the question. Okay, there's also another phrase that we could identify. What do you think? Not all. Fatima? Same amount. What's the term same amount is the same thing as saying equal parts, right? Same amount, equal parts, all means the same thing. The fact that they also have each in the question is indicating that we are going to go ahead and divide. This is going to be a division problem. Okay, so now when we're dividing, we're taking the total amount of yards that were lost and we're dividing it by the number of players, right? Total amount of yards that were lost, is that a positive or negative value? Logan?
Negative.
Negative, right? When we're talking about a total amount lost, the key word lost is indicating it's a negative. So we have negative 54. And then players, 9 players. Again, just like time can never be a negative, people can never be a negative either. So if we're talking about 9 players, that is a positive value. So we have negative 54 divided by 9. That's going to tell us how much each player lost. How much did they each lose? Jeffrey? Negative 6. Each player lost 6 points. And I'm even going to write that off to the side. Each player lost a total of negative 6 points, right? Negative 6 points each. Okay? What I want you guys to do is you're going to go through the rest of the problems. I think it's 14 problems. Yeah, 14 problems. You're going to, I know, we're going to do that together. You're going to go through the rest of the 14 problems. That's 12 problems for you guys to do on your own right now. I'm going to give you 10 minutes because it shouldn't take you too long. They're pretty easy to do. You're identifying your key vocabulary words, and then you're just going to go ahead and work it out. Tell me what the solution is. 10 minutes. All right, I'm going to go over these real quickly. So for problem number 4, you should have gotten negative 24 degrees total. You can just write down the problem and then the answer if you didn't catch up with it. For number 4, you should have done negative 20 times 15 and get negative 300. For number 5, you should have done negative 24 divided by 8, and that comes out to negative 3. For problem number 6, you should have had negative 88 divided by negative 4. You should have gotten 22, positive 22. Because again, you're asking how many days. Days obviously is going to be a positive. For problem number 7, you're going to take 3/4 and you're going to multiply it, because it says times, by 4 1/2. Now, for those of you who have forgotten how to do your multiplication in here with the fractions, if you forgot from the video, this N over D is your fraction button. Go ahead and zoom in on that real quick. I know the screen's literally light. But there's your fraction button, is that N over D, so you would type that in. And then you would type your fraction of 3. And then you would use these arrows here to scroll down to the bottom of it and type the 4. Now, you have to use the arrow to get out of that fraction. Otherwise, you're going to be doing everything inside the denominator. Then you'd hit multiply. And when you want to type a mixed number, if you hit the second button and then the fraction button, right above it in green is that mixed number. So the second button, fraction button, will provide to you a spot to make a mixed number. You would then do 4, and what was it, 1/2? Yeah, 1, and then use the arrow again, half, and then get out of there. You could also, if you wanted to, you could just type the number. You could say, okay, I'm going to do 3, and then hit the fraction button, and then the 4. It'll do the same thing. Okay, you could also type your fraction button. Oops, sorry. 3 fraction 4. You can get out of there. You can hit times, and then you could hit your fraction button again, and then your arrow to the left will get you inside of a mixed number spot. You could do 4 and 1/2. Okay, or you could convert that into a mixed number if you wanted to. It didn't matter. When you hit enter, it's going to give it to you in improper fraction form, 27/8. In order to convert that into a mixed number, you would hit second, and then the X10N button goes from fraction to mixed number. When you hit that button, it's going to pop up with what your original answer was. It's going to show you the conversion. You hit enter, and there is your mixed number. You need to make sure you play around with your calculator at home so that you get used to those buttons. Otherwise, you're going to be asking how to do something every time that we ask you to do it. And I'm not going to tell you over and over and over again how to do a fraction or a mixed number or how to convert. You guys need to make sure you're playing around so you can figure that stuff on your own too, okay? All right, so 27/8 or 3 3/8 would be perfectly fine for your answers. For problem number 8, 2/3 divided by 4 comes out to 1/6. For problem number 9, here's what I want to identify for you guys real quickly. When you see a fraction of something, the key word of, as if it's a fraction involved, fraction of something, that's also another way of saying multiplication. So go back to your first page, and on your first page, write fraction, and then keyword of, and then something. It's a fraction of the sandwich, or a fraction of the room, or a fraction of the people. Then that means you're multiplying by that fraction. Fraction of means you are multiplying by the fraction. You're taking the something and multiplying it by your fraction value. Fraction of something means you take something and multiply by fraction. Okay? A lot of people get confused by that, but that keyword of means you're going to multiply. So that's what we did here. We took the sandwich, how big the sandwich was, and we want to eat 3/4 of that sandwich, so we're multiplying it by 3/4. Even though multiplication usually means the value gets bigger, when it's a fraction of a value, it makes it smaller. Okay, so you should have gotten 57/16, or if you converted it, it would be 3 9/16. Okay, number 10. You should have had 16 3/5 divided by 4 1/5. You would get 83/21, or 3 20/21. Number 11. 3.75 divided by 0.25, you should get 15 sandwiches that we're being able to make. For number 12, take the cost, $15.99. You're going to divide it by 13, and it should come out to $1.23 for each movie cost. For number 13, you're going to have 0.8. You're going to multiply it by 5.35. It should come out to 4.28 or $4.28. You don't have quite a whole pound, so it's not going to be quite the $5.35. Okay, and then the last one, 18.5, and you're multiplying it by 2/5. Again, it's another one of those of, fraction of a value. So you have the amount of fruit. You're taking a fraction of that amount of fruit. So how much fruit did they actually eat? 7.4 pounds, or 7 8/5 pounds, or not 8/5, sorry, 4/5. Should be a 4/5, 7 4/5 of a pound. All those. Okay. Now the last page that we have, it is talking about conversions. So in order to convert from a fraction into a decimal, it's going to be a division problem. When you are converting from fractions to decimals, you are going to divide. It's numerator divided by denominator. You will be utilizing your long division skills for some of these problems. So For here, what you are doing is creating a situation in which you're taking a numerator and dividing it by a denominator. And what I also want you to notice is how a negative sign has an effect or does not have an effect on an answer. Okay? So in a problem or situation like this, we have a negative and then 3/5. What this means that we are doing, we are taking a negative, and in parentheses, we are doing 3 divided by 5. So if I type that into my calculator as I see it, I type my negative sign, which is down here at the bottom. Please do not get confused by that minus sign. The minus sign and the negative sign are different. There's your negative sign. Then we're going to put our parentheses. And then it's 3 divided by 5. Close your parentheses and hit enter, and you get your negative 0.6. For our second one, we've got negative 3 over 5. So that means I'm just going to take negative 3 and divide it by 5. Again, if I type negative 3 divided by 5, I get negative 0.6. If I do 3 over negative 5, so I'm going to take 3 and divide it by negative 5, I still get negative 0.6. But for my last one, when I have negative 3 over negative 5, so if I do negative 3 divided by negative 5, do I still get the same answer? No. I now get a positive 0.6. Still the same base, but a different sign. Okay, so keep that in mind, that when your fraction has only one negative sign written, whether it's in front of the fraction, on top of the fraction, or on bottom of the fraction, then your answer is always going to be a negative decimal. But when you have 2 negative signs in the fraction, notice that your answer now becomes a positive answer. So it's the odd one out. Yes, please go ahead and do the same thing for the other side. You are going to get a repeating decimal. Nope, you are going to, because I want you to write down the repeated value. You do get a repeating decimal. Just keep in mind, guys, your calculator rounds at the very end because it is a finite tool. It is a finite tool, meaning that it has to stop eventually somewhere. So when it stops, it naturally goes ahead and rounds that last digit, even though that last digit is not what it says it's going to be. How many of you have a 6 at the very end? It's not actually a 6. It's technically still going to be a 5, and then a 7, and then a 1, and then a 4, and then it starts the repeat process again. 2, 8, 5, 7, 1, 4. 2, 8, 5, 7, 1, 4. I'll show you actually in a Google calculator instead. Let's see here. Desmos calculator. Divided by 7. Okay, so here, the Desmos calculator goes a little bit longer. I know it's hard to see. But you'll see it's 285714, 2857, so they're going to keep going. It's just the 7 actually, when you're dividing by that 7, it is creating a repeated value here, okay? So you're going to put point, 285714, and then you put the bar notation over that entire thing. because it shows that that entire thing repeats. Bar notation. Oh, no. You're going to tell me, so if I go and ask Miss Lee, she says she's never taught you guys what repeated or decimals look like?
I've never heard of bar notation.
So she never said anything that, oh, if it's 0.3 and it repeats, you put a line above that. Who said she did?
I was in somewhere, so I didn't.
Okay. I'll ask her. I'll be more than happy to ask her. All right. Let's take a look here. So that's just called bar notation. Bar notation shows a repeat. Please make sure you understand and know that for now on. Shh. Make sure you understand and know that for now on. So here, again, you're just doing 2 divided by -7. That is going to come out to a negative 0.285714. And you're putting the bar notation over the entire sequence because the entire sequence repeats. For here, we've got a -2 divided by a -7. That's the only one that's going to come out to a positive 0.285714 with bar notation over the entire thing. Okay, here we have a negative and then in parentheses 2 divided by 7, and that is going to still be a negative 0.285714 bar notation over the entire sequence. And then -2 divided by 7 is still negative 0.285714 bar notation over the entire thing. Okay? So, here's the important thing to get out of this. That if you have those double negatives, it's going to result in a positive. But also something that you should understand is the idea of rational numbers. So at the bottom of here, I want you to write down what a rational number is. A rational number is a whole, an integer, or a decimal that terminates. What's another way of saying terminate? It stops. Terminates. So in parentheses, I'm going to put stops. So like what, 0.6 or negative 0.6? Or repeats, which means it has the same values repeating over and over and over again. That's what makes it a rational number. All your whole numbers are considered to be rational. All your integers, those positive and negatives, are considered to be rational. And then if you have a fraction or a decimal, when it's converted to decimal format, it has to be a decimal that terminates or it repeats. If it continues to go on and on forever with no repetition, we call that irrational. But you need to know the difference between rational and irrational. Now, for your assignment, and you have until Tuesday at the end of the day or end of class to have it done. It is a prodigy game. It is prodigy game. There are 50 questions embedded in, but again, you have until what day? Tuesday. So you've got 15 minutes right now. In 15 minutes, you should be able to get through at least 10 questions. Go ahead and get logged into Prodigy.